for the first part of this lab, you want to go through each compound and count the atoms. So for each one, you're going to write the element symbol and name and how many of each are there. So for silicon dioxide, there is 1 silicon, which is Si, and 2 oxygen, which is O, for 3 atoms total. You'll do that for each one of these as they go. Okay, so when you're balancing reactions, I went on to the next page. The whole idea is to start with a skeleton reaction. You're going to model 1 molecule of each one of these. So 1 molecule of silicon looks like that. And you're going to just use your markers and the sugar cubes, and you're just going to use different colors and write the letters on there. You can use little slips of paper, it really doesn't matter, but this is what the sugar cubes are for. Cl2 is a diatomic molecule of chlorine, which means 2 chlorines are bonded together. So right there I'm going to put 2 of them like that. I put a line where the yield arrow is to show that what's on this side must be the same as what's on this side. So on this side we have silicon tetrachloride, which is a silicon bonded to 4 chlorines. So the ideal here is that we want the atoms on both sides of the equation, which I'll separate with the pen, to match. You cannot add single atoms because of the subscripts. You have to add groups. So you can add another single silicon, you can add another group of chlorine, or you can add another group of silicon tetrachloride. Now, I look at this and I say, okay, there's 1 silicon on each side. I'm good with that. That's fantastic. But there's only 2 chlorines over here and 4. If I'm going to add chlorine to this side, I have to add it in a group of 2. So let me make another chlorine molecule. There we go. So now I count again and I say, okay, they balanced this time. 1 silicon, 4 chlorines, 4 chlorines. So this is a balanced reaction. Now you might be wondering what goes in on these lines. The coefficients. So just like in math class, if there's a single x, you don't put a number in front of it. So if there's a single molecule or element, you don't put a number in front of it. You can put a 1, it doesn't hurt. So if you just want to put something on the line, put a 1, but really you can leave it blank. So 1 silicon. Now how many chlorines? Now it's, yes, you're seeing 4 chlorine atoms, but Cl2. So how many groups of Cl2 are there? There are 2 groups of Cl2. So it's 2 Cl2. 2 times 2 is 4 total atoms. And how many groups of SiCl4? SiCl4 is a group, a molecule, so there's 1 whole group of that. Like I said, for the ones you can leave them blank, or you can do them there. So down here you would represent it with your molecules. You could draw it in. Now, since you're working like this, I would take pictures and just upload pictures of your little sugar cubes here. If you want to type it out, Si plus Cl2 plus Cl2 gives you an SiCl4. Or you could draw little pictures. I've done that before, where you do Si plus Cl, 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 Cl. Like that. So it doesn't matter how you draw that, but that's what you're doing. So basically, in order to balance a reaction, you need to make sure the atoms are the same on both sides. This is going to take some time to practice, so it might, you might need to work on this a little bit. So practice with these questions, and we'll come back and work on them together another day.